Okay, sorry. So good morning, everybody. Excuse me for the late. So I just want to present the system approach of ISOVER concerning the airtightness system and the on-site quality control we have developed to facilitate the control before the final test. So just to have a picture of all things we develop at ISOVER, and in fact we compose airtightness systems by different type of adhesives, the vario Gobain, vario multi-tape, different adhesives for the singular points like ISOstretch and vario pro tape. We have also different type of membranes, which are vapor barrier or smart hygroregulating membrane. And after we have also different pieces to compose all the systems and to realize different system on the wall and also on the roof. And to finish, we have also mastic, which is able to do the junction between the membrane and the different support like concrete, metal, and other type of support, in comparison with the adhesives, which are here to do the junction between the membranes only. And all the components of the systems are tested by different standards and European standards, and each component are tested both in shearing and peeling resistance. And for example, for the mastic, the shearing resistance is realized, the peeling resistance, is realized on different type of support. So we do it on concrete, on metal, and on wood, and different type of metals, in fact. Sorry. All these components are realized to help the workers to realize a good airtightness system in the individual houses. And after that, in France, we have different rules, and we have to measure the airtight in the house at the reception of the house. When the house is completely finished, we have to measure the airtight, and the measurement is realized in Q4. It's a surface measurement in comparison with the N50, which is a volume measurement. So after the systems, we have developed a special service so to help the workers to measure the airtight before the final test. And that is why we have, in fact, this evaluation of airtight is realized for private housing, at reception of new building to evaluate the performances, and in the course of the project to correct the possible defects before installation of the facing. Because it costs more to do another time the construction in comparison to correct the project before the end of the construction. At the end of the project, in order to ensure the official measurements carried out by an approved operator, we use also this new machine. I will present you after the machine. And the other type of evaluation we can do with this machine is the evaluation in multi-family apartment with independent batches. After that, this machine is able to control the airtight on the job site in a quality approach, because ISOVER test is the name of the machine. Is the first workstation of self-evaluation of airtight on sub-projects, because this machine is able to measure the airtight before the end of the project and to correct the defaults and to correct defaults before the end of the project. This machine is also realized to facilitate the coordination between the different installers. For example, if the electrical workers, electrician workers is working in the same time with the plasterboard, with the person who do the evaluation, with the integration of the insulation, for example, or the person who are here to put the different type of pipe, ventilation pipe, for example. So we have to determine who is responsible for the defaults, if you have a default. And this machine is here to help to coordinate on the job site the different installers. And that is why it's here also, this machine is also here to anticipate the potential issues before the final measurement. The principle of the machine. In fact, airtightness is measured, airtightness of a building is measured by sealing all the air entries and the air leakages, and by putting the house in depressurization or in surpressurization. After the official measurement is realized by a recognized operator, and but when we use the ISOVER test machine, the measurement is also carried out by in respecting standardization testing method that you know because it's the European one, the 13,829. After, you know, in France, we have, so as I said before, we have a special type of measurement because we don't measure the volume, but we use the surface of the surface of the different walls, and it's called Q4, and it quantifies the escapes of air of the building and is expressed in meters square of cold wall for walls and roof, sure. And 4 Pascal of difference in pressure external interior. But in fact, in this type of measure, with the blower door, for example, the blower door, you know, for the official measurement, in fact, we will measure from 50 Pascal to 4 Pascal, and we do a regression, and we take the average of the regression, because you know that at 50 Pascal the precision is better. After that, so the ISOVER test is the machine ISOVER has developed is really easy to use because you have just 2 buttons, and you have to put the blue tube, in the house, and the red one in exterior of the house. You have a door to put instead of the real door, and you have just to put the big ventilation in the special door, and just to turn the button and put the real surface indicated by the the control desk, and to perform evaluation of airtight compared to a target value. Because, for example, if you want to be in a house at a Q4 of about 0.6, for example, you put the machine at 0.6, and the machine, when you will do the measurement, the machine will be able to say if you are in the red part, it's the bad one, or if you are in the green part, and it's the good one. So this machine enables to locate the defects of ceiling, is really speed of implementation, easiness of reading, and reliability of the evaluation. After that, you know that in France we have special rules. These rules has given different performance to have if you want to build a house. For the single family housing, you have to reach 0.6 meter cube per hour per meter square, and for a multi-family apartment, you have to reach at least 1 meter cube per hour per meter square. To begin this type of performances have been given by F-Energy. It's a special label which is here to push the future rules. And now, since 2012, we have the rules are really installed in the French market. And if you want to build something, you have to respect this type of performances. That is why ISOVER has developed also different type of systems to help the person to reach this type of performances. And for the moment, it's just the BBC performances, and but in the future, in 2020, you will have to reach the positive energy performances of building. That is why it will be more and more complicated to reach this type of performances, and ISOVER will be here to help the workers to install with a better quality and easily and fastly on the job site. To conclude, we have just the characteristics of the ISOVER test. You have just to be aware that this type of machine is able to measure till a surface of 700 meters square, and you have to read the different of pressure on the digital display, and it's really easily to use. And for example, the feedback today is that we have it's useful in pre-control, because it's really easy to find the default defect after the measurement with something able to smoke outside or inside, and to see from where come from the defect. This type of machine can be rented in the retails, and because in fact the present users are big builders in particular, and which are able to build a lot of single family housing or multi-family housing, and for the little builders, it's possible to rent this type of machine in the retail. So just to conclude, I think this type of machine is a really good thing to control the performance of the airtight directly on the job site, and this machine permits to find the defects and to correct it before the final evaluation, which is realized by the official organism.